math lovers, welcome to notes number 30, lesson 1.7. I'm going to talk today about linear inequalities and talking about them in terms of absolute value. So before we get started, I want you to compare these three. I'm going way back to Algebra 1, and I want you to think about what's going to make this sentence true. Absolute value of x is equal to 2. Well, you know that is definitely going to be x is equal to 2 or x is equal to negative 2, right? And so on your graph, you would just put the 2 points, and you just make a little dots, right? You put your dots in there. Okay. How about greater than 2? X is greater than 2. Okay, so let's see, x could be, well, maybe let me do this graphically, okay? Negative 2, 0, and 2. I want the numbers to be greater than 2. So what numbers could I put in on my number line? I could put in 10, I could put in 50. Okay, those are all the numbers up here. Similarly, I could put the numbers in, because it's absolute value, the opposite of that. Negative 10, negative 50. So I'll shade in this part of the graph. Okay, so what am I saying? I'm saying, well, x could be greater than 2, or x is less than negative 2. Now, do you see what I did? I took this sign, the greater than sign, exactly the way it was written here, and rewrote it, and then I flipped both the inequality and the sign of the number. So now it's less than 2, okay? So it's different. How about if I have the absolute value of x is less than 2? All right, here we go. Let's see, less than 2. So I'm talking about down here, this section, right? But wait a minute, what if I put in like negative 10? Absolute value of negative 10 is 10. That's not gonna work. How about negative 1? Yeah, that'll work. So I'm talking about the region right here. So I'm saying x is less than 2, and notice I'm using the word and, here I used or, and x is, we're going to do the same thing, greater than, and I flip the sign, negative 2, okay? So I know this goes way back to what you're used to in Algebra 1, but I want to build upon it. So we're going to do much more difficult questions. Look at what we just did. We had a greater than, if my absolute value is on the left side, okay? So if it's on the left side, if I have a greater than sign, greater than, I used an or, okay? And here I had a less than, I used an and, okay? So again, absolute value has to be on the left. I like to remember this as go LA. Okay, we're all cheering for the Dodgers right now. Greater than is an or, less than is the and, so it's a go LA question. We're going to do a couple to practice these. All right, so looking at my first example that I have here, I have an equal to sign. So right up here, I have to think about, well, 2x plus 3 is equal to 5, or 2x plus 3, what's my other option, is equal to negative 5. Okay, so I need to just go ahead and solve those. 2x is equal to, subtract 3 from both sides is 2. So x is equal to 1, or bring the 3 over. 2x is equal to negative 8. X is equal to negative 4. So I have two solutions, again, connected by an or sentence, an or. I cannot say and, right? It can't be two things at the same time. There's absolutely no way it can be that. Okay, so that's my first example. Let's try a second example. All right, second one. I'm gonna try to, I've got the absolute value of 3 minus x is less than 2. Okay, now it's a less than. So I'm looking at my models up here. A less than, I'm going to use an and, all right? So I'm going to write it exactly in the same order that I have it. Drop the absolute value symbols, and I'm going to go ahead and use an and. I'm going to rewrite inside the absolute value symbols exactly the same way. And I'm going to flip my inequality to make this a greater, and I'm going to flip the 2 to make it a negative 2. That's the hardest part of the problem, really hardest part. Let's go ahead and solve it. Subtract 3 from both sides. So the opposite of x is less than negative 1. Whenever we divide by a negative, again, we have to change the direction of the inequality. So x is greater than 1. And, don't forget that and. Do the same thing over here. Subtract the 3. So negative x is greater than negative 5. So again, dividing by a negative, that would be positive 5. All right, so what's that going to look like on my graph? I can put that over here. The absolute value, let's see, I've got greater than 1. Here's my 1. Here's my 5. It's greater than 1, but yet less than 5, and I'm not including it. So, hey, how about I use a round bracket, right? A round bracket. I've been shading with the dots like you did in Algebra 1. You're in Algebra 2 now. You might want to give your answer as an interval, the interval between 1 and 5. You could also say it that way. Okay, that's a great problem. Let's try a third one. Oh, this is such a good one. Make sure I have enough space on the paper. Okay, so I'm going to, what if I said 1/2 is less than or equal to the absolute value of 2 plus 1/2 x minus 1. Okay, so what I'd really like you to do is to pause your video right now and then give this problem a shot and then come on back and look at it. Okay, all right, so hopefully you did it. And notice that this is not set up like the models, so we're going to go ahead and set up like the models above. This minus 1 is the first thing we need to change. So let's go ahead and add 1 to the other side. So I have 3/2 over here. And I'm going to flip the sides around. So it'll be the absolute value of 2 plus 1/2 x, right? And then I'm going to make this greater than or equal to, because I'm just flipping the order around, so the absolute value is on the left. And then I have 3/2. Great. Okay. So now it's a greater than. I look at my models up here. Greater than is an or, so it's a go question. So I'm going to say 2 plus 1/2 x is greater than or equal to 3/2. I write it exactly the same way, drop the absolute value symbols, and I use the word or in between. I'm going to write the absolute value symbols exactly the same, inside the absolute value symbols exactly the same. I'm going to change the direction of the inequality, and I'm going to change the sign. Okay? Hardest part of the problem is finished. All I have left to do is to solve. So let's go ahead and subtract 2. I can do that from all my sides here. Solve it simultaneously. I have 1/2 x is greater than or equal to negative 1/2. Over here I have 1/2 x is less than or equal to, that's going to be negative 3.5. I like fractions, so I'm going to say negative 7/2. I need to now multiply both sides by 2, so x is greater than or equal to negative 1. Same thing over here, multiply both sides by 2, so that would be x is less than or equal to negative 7. Okay, great. So remember, it's an or sentence. Or, let's see, I've got negative 7, negative 1, and 0. So it's got to be greater than negative 1. So here we are here. Use a round bracket. Greater than negative 1. Or less, oh, actually, it's a square bracket, right? Because it's or equal to. Oh, goodness gracious. And less than or equal to negative 7. And I know what you're thinking to yourself. Hey, how do I write that in interval notation, right? How do I do it in interval notation? Well, here, let me see if I squeezed it at the bottom of the paper. I would say that would be negative infinity all the way up to negative 7, round bracket. Union, use the union symbol. Square bracket, negative 1 all the way up to positive infinity. Okay, union, remember you put the two things together. Oh, such fun problems. Remember, go LA, we're cheering for the Dodgers, go LA. Greater than you're using an or, less than you're using an and. Have fun with your problem set.